Here we go. What's the domain? What can I plug in for? I can plug in anything I want except for what? I'm going to have to factor it to find out. So hopefully you factored this. And hopefully you factor the top to x plus 1 x times x plus 1, which is x plus 1 squared. The bottom factors the 2x minus 3 times x plus 1. And so when I look for the domain to answer part A, I can use any value I want except for what? I can use all real numbers except for -1, and I cannot use 3 over 2. So here we go. I'm going to write the domain is all real numbers except -1 nor 3 over 2. Make sense? That's what the domain is. Is the function continuous? Are there any breaks, holes, jumps, or gaps? If there's an asymptote, it's not continuous. If there is a hole, it is not continuous. So it is not continuous. Identify the horizontal and vertical asymptotes. Well, let's see. Horizontally. Let me break. There we go. Horizontally, I have an x squared over x squared. The degrees are the same. So that means I'm going to need to do y equals 1 over 2. 1 over 2 is the horizontal asymptote. What about the vertical asymptote? Which one of these, here's the horizontal, notice I labeled it h of a equals, interesting, there we go. Notice I labeled it horizontal asymptote is y equals 1/2. I have to know if you know whether it is 1/2, is it y equals, is it x equals, is it the horizontal, is it the vertical? Know the difference. I'm testing whether you know the difference or not. If you need help with that, let me know. I have a couple of tricks up my sleeve to remember that. Vertical asymptote, remember which one is a hole and which one's a vertical asymptote. If it cancels, if it can reduce, I should say reduce, if it can reduce, that is where a hole would be. But the vertical asymptote is where if anything doesn't reduce. So this 2x minus 3, that's where it would create the vertical asymptote, but not the hole. The hole would be at -1. Where? -1 where? -1 what? It's an ordered pair. You need to figure it out where it is. You plug it back in. Plug in the -1 here, plug in the -1 there, and simplify it, and you can find that -1 plus 1 is 0 divided by, and notice that you get -5 on the bottom, so it's just 0. The hole's at -1, 0. Sense? Piece of cake? Good. The last thing you're going to have to do is be able to make a table on your graphing calculators to compare a couple functions. So we have two functions here. F of x is this one, and g of x is this one, and we have a couple values we're going to need to plug in. So I'm going to show you this 100% on your graphing calculators. So here are your two functions. I want you to get your graphing calculators out. Substitute. If you need to press pause right now, go ahead and press pause. But what I'm going to do, okay, go ahead and press pause right now. If you need it. Everybody else, once you're ready, here we go. I'm going to plug in x squared in parentheses, x squared minus 9, end of parentheses, divided by parentheses, x minus 3, end of parentheses, enter. Now I'm going to do x plus 3, because it's what it asked me to do. Perfect. And then I'm going to need these values. So let me kind of show you here what I got going on. The x squared minus 9 is on top, and it's in parentheses, divided by x minus 3 on bottom, which is also in parentheses. And then under y2, I have this one. And, you know, for kicks and giggles, I'm going to make this one darker. I'm going to make it darker so I can tell it apart. Okay? But I'm going to need to use a table. Oh, I don't need a table. I just realized I'm using a table. I don't even need to make it darker or shade aside or any of that stuff. Never mind. Ignore that part. I'm going to go under table set. Table set. What do I want to start my table at? Well, when I look at this chart, I'm going to start at 0. So I'm going to press 0 here. What do I want to change my table with? I'm going to go up by 1s. Isn't that what this is going up? It's going up 0, then 1, then 2, then 3. Let's do that. Now that I have set my table set, I'm going to have auto, and then I'm going to go to the table, second table. And this is what I have. I have, when x is 0, the first function is going to have a value of 3. So does the second function. The first function, when I plug in 1, will have a 4. And so I can actually start filling this chart out. There's only one difference. Look at these two numbers. They're all the same except for one difference, which is the point of 3. What happens in the first function with a point of 3? You get an error. Why the error? You should know. Because you can't divide by 0. It's undefined. So you would fill this chart out very similar to this, which is we're getting from plugging into our graphing calculator. And it says make a statement about the results. These two functions are the same at all but one point. F of x has a hole. Where is the hole? The a-hole's in front, Mr. Bravo. I tell you, you guys are so mean. The hole is actually at 3, 6. You can find that by plugging in 3 into this equation, and that's where the hole would be. That brings us to the end of 7.3 notes. We're going to stop right there, and why don't you guys take about a 5-minute break, and then we'll start the 7.4 notes.